All right, so first section we're going to look at 5.1. We're going to break it into two parts. We'll do part of it today, and we'll do the other part tomorrow. Okay, so in this class, and probably a lot of your other classes, okay, you've done graphing before on this kind of graph. Okay, this is your Cartesian plane. Okay. It's broken up into four quadrants, your x and your y-axis. Break it into the four quadrants. And this kind of graph works great if you want to graph things that are straight lines. Okay? Very easy to graph something in y equals mx plus b form on an xy axis. But if you want to graph something that's circular, okay, it's not so easy to use this kind of graph. Okay. So another type of graph you can use, it's called a polar graph. Okay. If you have a graphing calculator, and you go to mode, okay, function is the kind of graphs like y equals mx plus b, but there's also a mode for polar. Okay, and if we have time, what I'll do is I'll sketch a circle using a Cartesian equation, and then I'll sketch a circle using a polar equation, and just show you how much easier polar is. Okay, today I'm not expecting you to know how to sketch a circle on the calculator. I purely just want to show you how much easier polar is for some things. Okay, so here's an example of a polar coordinate. Okay, basically what you have, instead of your xy axis dividing it into grid lines, you've got concentric circles coming out from the origin. Okay, you can call it the origin, or sometimes with polar axis they call it the pole. And your polar axis, that's the axis that runs left to right. And as you go around the polar coordinate system, 0 is on the right, 90 at the top, 180 on the left, 270 on the bottom. It's exactly the way we did it when we had unit circle trig. Okay? And in order to specify a point in polar, you need to write two numbers. Okay? Just like in rectangular. If I want to specify this point, I have to write two numbers, okay, an x value and a y value. Okay. Well, in polar, you don't have an x and a y value, but you have an r and a theta. Now, keeping in mind that a polar system uses these circles, anybody have a guess what r might stand for relating to circles? Yeah?
Radius.
Yeah. R is your radius. And theta represents an angle. Okay, so now we'll go over how you graph a point in polar. Just like when you look at rectangular. First thing you're going to do is look at the r. And you're going to move out the number of rings indicated by r. Now, when we start to move out from the pole, okay, there's two directions we can go. What about r do you think is going to control if you go to the left or you go to the right? A certain number of rings. Yeah?
How close it is to 180 versus how close it is from 0?
Well, when we start talking about 0 and 180, you're thinking of angles, right?
Radius. I think the radius is.
Okay, so for our radius, we can go either to the right or to the left, just like x, when you're graphing an xy point. What controls whether you go left or right? Yeah.
Positive, negative.
Right, if it's a positive or a negative number. Okay, so you're going to move out the number of rings indicated by r, starting from the pole. If r is positive, you're going to move that many rings to the right. Okay, if r is negative, you're going to start from the pole and you're going to move that many rings to the left. Okay, and just like on a regular grid, you can move in between rings. You can go 2.5. You don't have to always land right on one of the rings. Is there any question on that first step? You're either going to move right if it's positive, left if it's negative. All right. Now, once you move out to the correct ring, then you have to look at your angle. Okay? And from where you just moved in step 1, okay, and that's key. From where you moved in step 1, now you're going to move a certain number of degrees around the circle. Now, when you start moving around the circle, we don't really move left and right. What are the two directions you can move on a circle? Right, you're either going to move clockwise or counterclockwise. And again, that's going to be determined with whether the angle is positive or negative. Okay. If you have a positive angle, okay, if you have an angle greater than 0, you're going to move counterclockwise. It's just like we did when we measured angles. Counterclockwise is a positive angle. That's counterclockwise. If you have an angle that's less than 0, okay, or you have an angle that's negative, what direction do you think you'll move for that? Clockwise, yeah. And when they give you an angle, it can be in radians, it can be in degrees. Most of the time, I think when people get an angle in radians, they like to change it to degrees, so it's easier to work with. But that's up to you. As long as you graph it correctly, I don't care if you change radians to degrees. All right, so there's really like 4 different cases that can happen. You could have a positive radius and a positive angle, a negative radius and a negative angle, or one of each. Positive radius, negative angle, and the other way around. Okay, so we'll practice graphing all the different types that you could have. Right, so now we're going to look at graphing the first one where you have a positive radius and positive angle. Okay, so the first number tells me how many rings to move out. Okay, how many rings do I need to move out here? 3 rings. And should I start by going to the left or to the right? Yeah, Jared?
I think it's right.
Yep. So it's positive, so you're going to start by going 3 rings to the right. I'm just going to mark my starting point. That's not the answer. It's just where I'm going to start. Now from that point, I'm going to move 120 degrees. Okay, on my graph paper, I think each line is 15. So it's 15, 30, 45, 60, 75, 90. Okay. Some graph paper has more lines, some has less, just like regular graph paper. All right. So I'm going to move 120 degrees. And Nick, which way am I going to move? Clockwise or counterclockwise?
Counterclockwise.
Yep, counterclockwise. So I'm going to start from here. If I go all the way to the top, that's 90. And then how much past 90 do I have to go to get to 120? Go ahead, Nick.
30.
Yeah, so I'm going to go 30. And that's the point 3, comma 120. Okay, that's it. Any questions on how I graph that? Okay, so pretty straightforward, but we'll talk about a few other things with graphing in a second. How about 5 comma pi over 4? Alyssa, what could I do first to make that a little easier? Yeah, if you're not comfortable with where pi over 4 radians is, just change it to degrees. Okay, and Rebecca, what is pi over 4 radians in degrees? Now, do you remember how to find it if you have to?
No, no.
Not sure. Can anyone help her out? What do you do? Sam?
Is it 180 over 5?
Yeah, you take and multiply by 180 over pi. So the pi's cancel, and you're left with 180 divided by 4. So just anyhow, what's 180 divided by 4? Not sure. Well, another way you can divide by 4 is take half of something and then take half of it again. So what's half of 180?
90 and then 45.
And 45. Yep, good job. Okay, so we've got 45 degrees. All right, so Eric, what ring am I going to go on to? Yep, fifth one. And should I go 5 to the left or 5 to the right?
5 to the right,
And how do you know that?
because it's 45 degrees.
Careful, the 45 degrees doesn't tell me which ring to go on. You pick the right number. What number tells me the ring? The 5. And that number also tells you the left and the right, not the 45. Just whether it's a positive or a negative. Okay, so since it's a positive 5, that's why you're on the 5th ring. Okay, so I'm just marking my start point. I'll erase that when I'm done. And now, Brianna, I'm going to go 45 degrees which way?
Counterclockwise.
Counterclockwise. 15, 30, 45. Okay, on my graph paper, all the 45 degree angle lines, they're all in red, so you can find them a little easier. And that's where your point is. Any questions on that one? Yeah.
On the test, are you going to give us the graph?
On the test, the graph will already be printed on the paper. Yeah. For homework, I only have rectangular grids, but if somebody wants polar grids, let me know. You could just Google polar grids, and they'll put like 4 of them on a page, and I can just print that. Okay, so if anybody needs some, just let me know, and you can use the same grid for all the problems in your homework. You could just label this one like, that's number 1, number 2, and so on. You could just label them like that. All right, let's try this one. So we got 5, negative 210. Okay, so Paige, what ring am I going to be on this time? Yep, 5th ring. Should I go left or right?
Right.
Yep, so we're going to start right there. And we're going to move 210 degrees. And which way am I going to move this time, Dan? Yeah, I'm going to move clockwise. So what I usually do is, if I go halfway, that's 180. And then 210 is 30 degrees beyond that. So there's your point. Now, if you compare this one to the last one, okay, let's say you didn't have the coordinate written. All you had was the point. Can you tell which way you went to get to that point? Is there any, like if I just gave you this, can you tell how I got to the point, if I went clockwise or counterclockwise? No. So, in a second, that's going to lead us into talking about how there might be more than one way to write a point in polar. Okay? There's more than one way to get to the same point. Right? You have 4 different directions you can pick from. You can start by going left or right, and then from there you got clockwise and counterclockwise. In fact, we'll try that on this one. Okay, these are the ones that most people make a mistake on when the radius is negative, and I think it's just because they forget to go the correct way. So I know I'm on the 3rd ring, but Katrina, am I starting 3 units to the left or 3 units to the right?
3 units to the left.
To the left. That is my start point. Now from here, I am going to move a certain number of degrees. Let's change pi over 2 into degrees so it's a little easier to look at. Shakira, do you remember what pi over 2 is?
90.
In degrees? Yep. 90. So Skylar, from where I marked this point, I'm going to go 90 degrees which way? Clockwise or counterclockwise? Yep.
Counterclockwise. Counterclockwise.
Yep, counterclockwise. Okay, because you have a positive angle, we're going to go counterclockwise. And that's where you end up. Okay, for this one, I'm going to draw how we got there. Okay, we went this way and that way. Can somebody give me a different coordinate other than negative 390 that would get me to the same point? There's a few ways you can do this. Yeah, John?
-3, -270.
-3, -270. Let's check. Okay, so if I go -3, still bringing me to the left 3. But now -270 means to go clockwise, and 270 is 3/4 of the way around. So now he's going this way. Yep, perfect. What's another way? There's a couple ways. We've got the negative positive. We've got the negative negative. Yep. 3, -90. All right, let's check it. So we're going to go right 3, and then 90 degrees clockwise. So right 3, 90 clockwise. Perfect. And there's one more. Yep, Jared.
3, 2, 7.
We could do 3, 270. So that means right 3 units, and then 270 degrees counterclockwise. So how many different ways are there to get to that point? 4. Okay, and that's true for any point in polar. There's 4 different ways you can get to it. Now, someone might say, well, could you go like this? Could you go right? I'm just going to go to a different ring so it doesn't look as confusing. And let's say you wanted to stop here. Could you just say, oh, I'm going to go around an extra time, make an extra revolution? You could, but that's still the same thing as going to the right and going counterclockwise. Okay? Going around more than once and then stopping, that's just a repeat. Okay? So those are the 4 basic ways. And what's nice is when you find them, you have every combination of positives and negatives. Both positive, both negative, one of each. Okay, so any questions on that? Okay, if you get stuck figuring out the different ways, I think one of the easiest things to do is to draw it. Okay, that helps. Or if you can figure out some of them, you might be able to get the other ones. Like, if you have -270, does anyone remember what you add to it to make it a positive angle? Yeah, you add 360. So take -270, 270, and then add 360, you get 90. And that's the answer right above it. So if you remember that, there's some tricks you can use if you can't draw it to find it by adding or subtracting 360 to the angles. Okay? Same thing with the one below it. Okay, any questions on that? Now, can you do that in Cartesian? Okay, I gave you one way to get to this point. Is there another coordinate to get to that same point? Okay, John?
No.
No. Okay, in Cartesian, there is only one way to get to every point. Okay, so polar, little different. All right, so we already kind of did a negative, but we'll practice one more. So -2, -180. Jake, can you tell me how to graph that one?
Your second, the negative second, right? You have 2 rings out on the left-hand side,
Okay, so I'm going to go 2 rings out, and which way am I going to go?
clockwise.
First, I just need to know, is it 2 rings right or 2 rings left?
2 rings left.
Yep, so I'm going to start right here. And then the negative angle says to go which way?
Clockwise.
Clockwise. So I'm going this way. Okay, and I end up right here. When you sketch it, I don't need you to show me how you got to the point. I'm just going to see if you have the correct point. What would change if I made it -2, +180? Nothing. Okay, the point would end up at exactly the same spot. Okay. If you go halfway around, it doesn't matter which way you go. Okay, 0, 300. Okay, where's that one going to end up? At where?
Still at 0.
Yeah, it's going to end at 0, but what about the 300? What does that do?
Nothing.
Yeah, not really. It doesn't really do anything, right? Because your radius is 0, you're just spinning in place. Okay, so when you draw it, just put your pencil down and spin 300, and then just stop. And that's your point. Just make sure you do that spin, though. I'm going to look for that. Okay, so 0, anything is always, do the spin. It's always at the origin. Right? How about if we switch it? Okay. If you put the 0 as the degree, is that always going to be at the origin? No. Where would a point always be if it's something, 0? It's always going to be somewhere on that red line, okay? Somewhere on that polar axis. Okay? So in this case, it's just 1 unit to the right. Okay, so any questions on that? Okay, so just be careful when you're graphing a negative radius. Some people, they just go to the wrong side, and it's just a simple mistake, but an easy one to get wrong. All right. What's pi over 6 in degrees? Remember, pi is 180. So it's 30. Okay, so I'm giving you the point 3, 30. What I want you to do is write it 3 different ways. Okay, I already did one with you where I wrote it 4 different ways. But I'll give you the criteria that I'm looking for. Okay, I'd like you to write it the first way, keeping the radius positive, and I want you to give me an angle between 360 and 720. Okay, remember, we talked earlier in the year, and I think I just asked you a few minutes ago, what you can add or subtract to an angle to make it bigger or smaller. Okay, so if you need to make an angle bigger, just think of what you can add to the angle, and it just makes it bigger. Okay, the second way I want you to try to write the point, I want the radius to be a negative number, but I want the angle between 0 and 360. Okay, we did one like that with the one I did with you. Okay, and we also did one like the third way. This time I want the radius to be positive, but I want the angle negative. So I want to go the other way. Okay, and they could write this kind of problem different ways. They could say positive radius, clockwise movement. Okay, if they wrote clockwise movement, you would know that means it's a negative angle. If they said counterclockwise movement, you would know they're looking for a positive angle. Okay, so take a second, a minute, see if you can figure out 3 different ways to write that point. You don't have to do it in radians. You can do it in degrees. All right. So my suggestion while you guys were doing that is to draw a picture, and that's what I'm going to do. Okay, so they're giving me the point 330 degrees. Right there. So now the first way they want me to rewrite it is they want the radius to be positive. Now you're pretty limited with the numbers you choose for the radius. There's only 2 numbers you can pick and land on the third ring. What are the 2 numbers you always have to pick for your radius? It's either got to be 3 or -3. You can't pick anything else for the radius. So this time, they want a positive radius. So what am I going to pick? Which one? 3. And now they want an angle between 360 and 720. In other words, they want me to just go around 1 extra time and stop. So I'm going like this. Okay. And I need to figure out how many degrees that is. Right. Anyone figure out how many degrees it is to go around that extra time and then stop? Yeah, how'd you get 390? Did you do it visually, or did you just do some arithmetic?
I did it like that.
You did it with the picture? Yeah, so you can do it with the picture, and you can see if you go all the way around once, that's 360, and then you're going 30 more. So add 30. If you don't want to do it with a picture, all you had to do was take the angle and add 360, and that makes it bigger. All right, second one. All right, so Jesse, this time they want me to do it with a negative radius. So what would I have to pick for my radius this time?
-30.
Yeah, that's the only option. It's got to be -3. So I'm going to start here. And now I'm just going to figure out which way do they want me to go to get to that point, and then I'll count it out on my graph. So Karen, are they asking me to go clockwise or counterclockwise? Yep, it's a positive angle. Okay, counterclockwise. So they want me to go just like that. And Brian, how many degrees is it to go from here all the way to that point?
The 210.
Yeah. First you go halfway. Okay, that gets you to 180. And then you got to go 2 more lines on my grid, which is 30 more, brings you to 210. Perfect. Okay, and the last way, we'll do it with a positive radius. So it's got to be a 3. And now they want a negative angle. Marquise, what direction is a negative angle?
Clockwise.
Clockwise. So I am going, let's mark my start point. And I'm going clockwise. So I'm taking the long way to get over there. Okay, first thing I'm going to do so I don't forget, if I'm moving clockwise, it's a negative angle. So put that first. And now I just need how many degrees did I move. Right, so Selenia, do you see how many degrees I moved to get to that point? Yeah, 330, right? Because this little section here is 30. And I almost went all the way around, except I didn't go the last 30 degrees. Okay? So that would be 330 degrees around. Okay, so as I said, when you do a problem on a test, I might write my answer as a positive, positive. You might write it as a positive negative. You just have to understand they're the same thing. That's all. Okay, so any questions on that? Okay, so last thing we'll finish up with is how we can change a point from polar, okay, which is what we're learning, back to what we are more familiar with, okay, rectangular. All right, so if they give me a point in polar, I would know two things. Kyle, can you tell me one of the two things that if you're given a point in polar, you must know?
The radius.
Yep, you would know the radius. And can you tell me the other thing too? You'd know the angle. Okay, so here's a point. It has a radius, which I'll call r, and it has an angle, which I'll put right there. So my goal is, instead of writing it as a radius and an angle, I want to figure out how far to the right and how far up. Or it could be left, doesn't matter. Any thoughts on what I can do or what I can add to this picture to turn it into a certain shape?
Make it a right triangle.
Yeah, how would I make it a right triangle?
Just draw a line. Pretty close.
Actually, that did work out okay. I was trying to be more sarcastic. There's a line.
From the end of the radius down to the x-axis.
Yeah, so from the end of the radius, and specifically I'm going to draw it perpendicular because John said make it a right triangle. All right, so there's my triangle. Now, in order to convert this point into an x and a y value, what I need to find is two sides of this triangle. I need to find how far do I move horizontally? That's your x. And then how far do you move vertically? That's your y. Okay, so you're going to go to the right this amount, and then up that amount. That's x, and that's y. And remember, they're going to give you r, and they're going to give you theta. So you will have numbers for r and theta. All right, let's start by figuring out x. Okay, so I'm going to circle some things like I've done before. I'm going to know r, I'm going to know theta, and I want to find x. What trig function could I use to find x? My choices are sine, cosine, or tangent. Connor? All right, what's the name? Can somebody tell me the name of the side next to the angle? That's adjacent. And what about the side across from the 90? That's your hypotenuse. So for this one, I'm asking about x. So I'm using adjacent and hypotenuse. What? That's cosine. Yep. So I'm going to write down cosine of my angle, which again, I will know this. I'll have a number. Equals what goes on top? Connor? Adjacent over hypotenuse. Now my goal is to get x by itself. Okay, I want a formula that can calculate x. So how do I get r on the other side? Yeah, multiply by. Perfect, yeah. Just multiply by r and multiply by r. So r cosine theta equals x. Okay, so now we know they'll give us r, they'll give us theta. Just plug them in. There's your x value. All right, now let's do the same thing, except we'll find our y value. So this time I'm going to use r, because that'll be given. Theta, that'll be given. And I want y. So what trig function involves hypotenuse and opposite? Sine. And can you set that up for me, Kyle?
Sine of your angle is equal to y over r.
Y over r. And now I want to do the same thing I just did. I want to get a formula for y. So Katrina, could you tell me how I get r on that other side?
Multiply by r.
Yeah, multiply by r, and there's your formula for y. So these are the two formulas you need if you want to convert something from polar to rectangular. Okay? All based on a triangle. You don't need to draw the triangle each time. All you need is the two formulas. Okay, the same formulas we just had on the other page. Okay, so if you've got a point in polar that has a radius and an angle, use these formulas to convert to rectangular. Okay, in other words, x, y's. Okay, so we'll finish up just by trying two examples where we change rectangular to polar. I'm sorry, polar to rectangular. Okay, and it doesn't matter if they give you radians, that's fine. What I'm going to do if they give me radians, I'll just put my calculator in radians. Okay, if they give me degrees, I'll put my calculator in degrees. All right, so Dan, can you remind me, what's my formula to find the x value?
Radius times cosine theta.
Perfect. Radius times cosine theta. What's my radius here? 6. And what's my theta? Pi over 6. Okay, I'll do that in a second. Let's set up our formula for sine. How about Nolan? What's the formula for the y value?
It would be the circle of degrees, y equals sine pi over 6.
So can you tell me what I'm going to put here, and I'll type it in exactly.
It would be 6 sine pi over 6.
Perfect. Yep. 6 sine pi over 6. Okay, so now we'll just type them in. Before I type them in, what should I check on my calculator? Yeah, check the mode. I'm already in radians, so that's fine. So 6 cosine pi over 6. And I'm just going to round it to about 5.20. Okay, so x is 5.20. And y, just change that to sine, is 3. Okay, so make sure you write your final answer as a coordinate. X is 5.20, y is 3. Okay, any questions on that? All right, so now what I'm going to do is I'm going to check that answer is right using the smartboard. Okay, the way I can do it is graph the original, 6, 30 degrees. So 6, 30. And now, if I take a rectangular grid and drop it right on top of this one, as long as the rectangular grid spacing is exactly the same as my ring spacing, that point should land exactly at 5.2, 3. So I just have to drop the right size grid on top of that, which hopefully I can find. Okay, so any questions on that graph? That's just the original point. All right, so now let me see if I can find the rectangular one. That's exactly the same size. I think it's this one. Yes. Does that point look like it's at a little bit more than 5 and up 3? Yeah, so that's exactly where it should have ended up. It's perfect. I wait all year to do that. It's like the coolest thing I do all year. Right there. That's it. All right. So any questions on that? So you probably on your Chromebook, I don't know if you might be able to do something like that.
Yeah.
Probably not with the same software, but you could graph a point in polar and then just drop the different grid right on top, and you can see the point should stay right where it is, and the grid behind it changes to your answer. All right, so try that one. Just see what you get for x and y. Round it to 2 decimal places if you have a calculator. If not, just set the formula up, and we'll solve it together. All right, so somebody that got the formula for x, what was your formula for that? Yep, Shakira?
4 cosine 20.
4 cosine 120. Okay. Anybody else have 4 cosine 120? Negative 4. Perfect. And the y value? Or just tell me the formula. Yep.
Negative 4 sine 120.
Yep. And now if you do your x value, anybody get the answer for negative 4 cosine 120? Comes out, yeah. A lot of times one of them comes out to a nice number. I'm going to guess this one did not. What was the decimal for the y value? Negative 3.46. Okay, thank you. Okay, so there's your x and y value. And there it is as a coordinate. Okay, any questions on that? Okay, so tomorrow we'll pick up with doing the reverse of this. Okay, we'll change it back the other way. Okay, so the homework, this week it's all in the book. I know some weeks we have like the worksheets. Okay, but this week it's all in the book. 12 to 26 and 40 to 46, all evens. Okay, just do all evens.